Okay. We will be discussing inverse Z transform calculations, but for this we will take H Z to be rational function. Okay, not any arbitrary capital H Z, but typical H Z rational function, which is basically a transfer function of a linear shift invariant system we have seen, that is typically of the form some B 0 constant plus B 1 Z inverse, B 2 Z inverse 2 dot 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 dot, maybe B q divided by 1 plus A 1 Z inverse plus A 2 Z inverse 2 dot 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 A p Z inverse p. There will be some ROC given, that is some mod Z is given for this, some ROC. R plus can be infinity, so it is outside a circle, causal. R plus can be finite, but R minus can be 0, so it is inside a circle, or otherwise both are finite, so it is both sided. All those possibilities are there, but this is what is your H Z. How to find out H n? How to find out? There is a question that we will get by inverse Z transform. For that, first thing you should ensure that numerator polynomial is a polynomial in Z inverse, right? Z inverse you can replace by say some constancy called x. So, it is b 0 plus b 1 x plus b 2 x square up to b q x to the power q, and in the denominator 1 plus a 1 x a 2 x square dot 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 a p x to the power p. You first make sure that the numerator polynomial power, that is q, is less than p. If it is not less than, we will divide the numerator by the denominator first, like an algebraic division, okay, and take the remainder out. Quotient will come out separately, and remainder by this denominator will be the remaining rational part, and we will carry out inverse Z transform of that. Let me explain through an example. Suppose H Z is given as 1 plus Z inverse plus 2 Z inverse 2 plus say 4 Z inverse 3, and here it is say, just a minute, okay, and it is given mod Z, sorry, this is ROC, an outer circle of radius half, inner circle of radius 1 by 4. So, the region between them is having Z's with mod Z between these two. So, that is the region of convergence given. Okay. Now, here you see numerator is having power 3 in terms of x, if you call Z inverse x in terms of, and denominator has power 2. So, obviously, here numerator has higher power than 2 than denominator. So, what I will do? We will divide the numerator by denominator. Okay. So, I write for your convenience, I write Z inverse, replace Z inverse by x. So, I have got 4 and I divide. So, 4 x cube plus 2 x square plus x plus 1. I am writing from the other way, highest power and lowest power. 4 x cube plus 2 x square plus x plus 1, and I am dividing it by 1 by 8 x plus minus 3 by 4, 1 by 8 x square minus 3 by 4 x plus 1. All right, if I divide, what will I get? So, you have to multiply by how much? 32. Okay, 32x. 32x means it will be your 4x cube minus some x square 8. So, 24x square plus 32x. So, this cancels, this is 26x square minus 31x and plus 1. So, next time you multiply by 26 by 8. Okay, so you get 26 x square minus 3 by 4 into 26 by 8, 26 by 8, that is 39 by 16 x plus 26 by 8. This is cancelled. This will be something. This I do not calculate here. It is how much? It will be minus 33. So, 7 by 16. That much x. Okay, 31 and 39 by 16 means what? 2, 16 into 32 and 7. So, 7 by 16. So, 2 and 31, 33, and this will be your 4 okay, this. So, then this entire polynomial I will write as 8z. This quotient will come out. So, 32. You see, what is this after all? That is this into this plus this is equal to this, right. So, this by this is so much of quotient coming out, and then the same numerator, quotient, okay. That is I write in terms of Z inverse now. Same numerator, sorry, numerator is this part, remainder part, that is minus 33 Z inverse plus 4 1 by 4 divided by denominator is same, that is 1 minus 3 by 4 Z inverse plus 1 by 8. Okay. Quotient and remainder by divisor, that is standard thing. Okay. That is this into this plus this equal to this. All right. This we know. We know that if you are dividing, if you are doing this, if you are dividing y by x, if quotient is r and remainder is z, then y is r times y is what? Y by y is r times x plus z. R times x plus z is y, which means y by r is x plus z by r. Okay. Y by x is r, that is quotient comes up and remainder by same x. Okay, that is what. So, quotient comes up and remainder by the divisor. Okay, that is what comes. Now, this part, if you take the inverse Z transform, Z inverse, there could have been Z inverse 2, then Z inverse every. Z inverse means, I mean, we have seen delta n has got Z transform 1. So, delta n minus 1 will be having Z transform Z inverse times 1. So, this will nothing but this will give rise to 30 in the, if you take the inverse transform of that, it will give rise to just this 26 by 8, it will give rise to 26 by 8 into delta n, because delta n has Z transform 1. So, 26 by 8 will be the Z transform of 26 by 8 delta n. So, that will be Z transform will be 26 by 8 into 1, this will be. So, this part is easily doable. So, we will be then targeting, I mean, rational functions of this form, where numerator is a polynomial, denominator is a polynomial, both in terms of Z inverse, which you can call x, but numerator degree power is less than the power of the denominator. How to take the inverse transform of those part, that is what we will be focusing on. The quotient part will be having terms Z inverse 2, Z inverse 3, Z inverse gives rise to delta n minus 1, Z inverse 2 gives rise to delta n minus 2 dot 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 dot. Okay, that we can get directly. Problem lies here. So, I will now consider this kind of expressions. But before we do that, some basic facts will be of use. Suppose I give you a to the power n u n. there is a right sided sequence. Okay, its Z transform is, if you call it H n, its Z transform will be what? Outside a circle, and we know that summation a to the power n z to the power minus n u n. So, it will be from n equal to 0 to infinity. So, a to the power 0 z to the power 0 1, then a z inverse a square z inverse 2 dot 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 dot. So, this will be converging if mod a z inverse is less than 1. Okay, then it convert this to, we have all done it in school, 1 plus x square plus x cube dot dot dot, it convert this to 1 by 1 minus x if mod x is less than 1. Instead of x, I have a z inverse. So, if that is true, it will converge to 1 minus a z inverse. But if it is true, this will mean a z inverse means mod a by z, and mod of a by z is mod a by mod of z. This we have seen earlier. It is less than 1, which means ROC will be outside a circle of radius mod e. So, if I give you this sequence, Z transform of this, but ROC is this mod Z greater than mod e, that is 1. On the other hand, suppose I have H n is equal to minus a to the power n. What is this sequence? If you start at put at n equal to 0, u minus 1, that is 0, n equal to 1, u minus 2, 0, n equal to 2, u minus 3, 0. So, n equal to 0, n equal to 1, n equal to 2, n equal to 3, as you go rightward, this value is 0. But if you start at n equal to minus 1, so minus minus plus, plus 1 minus 1, 0, u 0, that is 1. So, it will be minus a to the power minus 1. Okay. So, if you have a time axis and suppose this is your origin, then these values will be all zeros. From here it will be, that is at minus 1, its value will be minus a to the power minus 1. Then at minus 2, its value will be minus, right. If you put n equal to minus 1 here, minus minus plus, plus 1 minus 1, 0. So, u 0 we all know 1. So, minus a to the power minus 1, because n is minus 1. So, h minus 1 is minus a to the power minus 1. Then you put n equal to minus 2. So, minus minus plus u 1, which is again plus 1. So, minus a to the power minus 2 dot 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 dot. So, its Z transform, if you write the expression now, it will be minus a inverse, you have to start from here, z to the power minus n, in the Z transform formula it will be minus n, but n is minus 1. So, it will be z to the power plus 1. Then minus this z to the power minus n, n is minus 2. So, minus minus plus z square. And you take minus out, a inverse z out. So, it will be 1 plus now, this is an infinite sum. Again, this will converge if a inverse z, its mod is less than 1, which means mod of z by mod of a less than 1, because a inverse z means z by a, mod of z by a is same as mod of z by mod of a, this is less than 1, which means mod z less than mod a. So, here ROC will be inside a circle of the same radius mod a, and in that case the summation will be, here it is as it is, and this will be 1 by 1 minus, if you call it x, 1 minus x, a inverse z. And now, if you divide numerator and denominator by a inverse z, you have minus 1, this becomes minus 1, this becomes a z inverse. I divide numerator by a inverse z, so that cancels, you get 1. Denominator I divide by a inverse z, so this cancels with a inverse z, 1, and here 1 by a inverse z, which is a z inverse, okay, and minus sign, and then you minus, you observe in the denominator, it becomes 1 minus a z inverse. So, I worked out this example earlier, same expression you get, but ROC is different here, ROC is inside the circle, and as a result your time domain sequence is different from this. This was right sided, it is left sided, it started at 0, it started at minus 1, okay, two different sequences. having the same expression for Z transform, but different ROCs. Okay, we will use these things in a general inverse transform calculation. Okay. Now, suppose I have got one expression. See 1 minus, just a minute, this is given to you, and ROC is given as, there is an outer circle of radius 1 by 3, inner circle of radius 1 by 6 in the intermediate region, the region in between the two circles, okay, ring like region, there is the ROC. Now, here you see numerator we are considering to have degree less than the degree of the, or order less than that of the denominator. If you call Z inverse to be x, it is 1 plus x, so x to the power 1, the power of the numerator polynomial is 1, degree 1, degree of the denominator is x squared, that is 2. So, that means, if I earlier told you that if the degree of the numerator is greater than or equal to the degree of denominator, you divide the denominator by the numerator. So, the remainder comes out, that you can handle separately easily, and then remainder part divided by the denominator. Remainder will have degree less than denominator, because that was the divisor. Remainder cannot have the same degree as the divisor. So, it will have degree less than that of this denominator. This will be handling separately, and we will follow a method called partial fractions. Okay. For this, you keep the numerator as it is, factorize this polynomial into first order factors. Okay. This polynomial, if you call Z inverse x equal to x, if you say Z inverse is x, it is 1 minus half x plus 1 by 18 x square. Okay. You can do factorization, you can take 1 by 18 out, so x square, and then it will be minus 9 x plus 18, if you want to do that way. So, it will be 1 by 18 x minus 6 x minus 3. Okay. So, it will be, you can take 1 by 6 inside, 1 by 3 here. So, it will be 1 by 6 x minus 1, 1 by 3 x minus 1, and then equivalently 1 minus 1 by c x, take minus out, and x is Z inverse 1 minus, like this. We always prefer this kind of form, like this, constant and then something into Z inverse, not in terms of Z, we always prefer in terms of Z inverse. So, this is a factorization. So, you see this has got two poles at Z equal to 1 by 6, 1 by 6 inverse and 1 by 6 cancels 1, 1 minus 1 0. So, division by 0, this does not exist. So, H Z does not exist at Z equal to 1 by 6, similarly at Z equal to 1 by 3. That is why ROC could be either outside the circle of radius 1 by 3, so it does not contain the pole, it is fine, or it can be between the two circles, not touching the circle, but between the two, one is of radius 1 by 3, another of radius 1 by 6. So, intervening region, there Z cannot be 1 by 6, Z cannot be 1 by 3, or ROC could be mod Z less than 1 by 6. So, there is the inner circle of radius 1 by 6, you go from the circle up to the origin, that region is, Z can never become 1 by 6 or 1 by 3, that is again free of poles. ROC cannot contain poles. So, 3 possible ROCs. Out of this, I consider this as an example. For this ROC, you have to calculate the inverse. This, as before, since you are not very expert in this, you can continue to call it x, x, x. So, you have got 1 plus x divided by 1 minus 6 x 1 minus 1 by 3 x. These suppose I write as, and then I will explain how can I write like this, as one factor, another is okay. Why? Because if you add the two, a and b are two constants to be evaluated. Why you can write like this? Because if you add the two, denominator will be product of the two, which is here, and the numerator will be a into 1 plus b into 1, that will be a constant, that will equate with 1, and then a into minus 1 by 3 x plus b into minus 1 by c x, that I will equate to x. So, numerator will be of this form only, some constant and something x. Okay. So, what will be a? To obtain a, this is your h x, right. You multiply left hand side and right hand side by this factor, that is h x. Left hand side if you multiply by this factor 1 by 1 minus 6 x, right hand side this cancels, a plus b into 1 minus 3 x into this, I am multiplying right hand side also, left hand side also by this factor. So, this factor when I multiplied this and this cancelled, it came here, they cancelled, I got a back. But in case of b, no cancellation. So, b by this 1 minus 1/3 x remains, and then multiplied by that 1 by 1 minus 1 by 6 x, left hand side this. Now, if I want to make this 0, that is if I take x equal to 6 on the left hand side, right hand side also it will be 0. So, I will be left with a, this part will be 0, because 1 minus 1 by 6 x at x equal to 6 will be what, 0, 1 by 6 into 6, that is 1, 1 minus 1 is 0. So, for x equal to 6, this part goes, I am left with a, and a will be h 6 into 1 minus 1 by 6 x. But if I multiply h x by this, you see this h x, it will cancel, this factor will cancel this denominator, right. So, what I will be left with is this, I will be left with, if you multiply h x by this factor will cancel the denominator. So, that was 1 plus x by 1 minus 1 by 3 x. Here I will be replacing x equal to 6, because on the right hand side I am replacing x equal to 6 here. X equal to 6 means 1 minus 1, 6 cancel, 1 minus 1 0, this part goes, I am left with a. So, right hand side is a, left hand side h x into 1 minus 1 by 6 x. If you take this h x multiplied by 1 minus 1 by 6 x, that cancels with this, you are left with 1 plus x by 1 minus 1 by 3 x. You put x equal to 6 here, that will give you a. So, if you put x equal to 6, you have 6 plus 1 7 divided by 1 minus 1 by 3 into 6, that is 2, 1 minus 2, that is minus 1, which means a is minus 7. Similarly, find out b. You find out b. Okay. How? The same way, I multiply left hand side and right hand side by this factor now, 1 minus 1 by 3 x. So, 1 minus 1 by 3 x, 1 minus 1 by 3 x, they cancel, I am left with b. And in case of a, 1 minus 1 by 3 x here divided by 1 minus 6 x. Right hand left hand side h x into 1 minus 1 by 3 x. So, that cancels with this. If I take h x multiplied by 1 minus 1 by 3 x, that cancels with this guy. So, I am left with 1 plus x by 1 minus 1 by 6 x. Now, right hand side, if x is 3 cancels, 1 minus 1 0, this part becomes 0, left with b, I am left with b. So, right hand side, if I also have to put x equal to 3, so that will give me b. How much is b? If we put 3 here, 3 plus 4 minus, so 4 minus 1 minus half, so minus 8. Now, if you put them back here, you can verify, that is 7 by 1 minus x plus 8 by sorry, minus 8 by 1 minus 3x. Okay. This is minus 7, b is plus 8, because if you put x equal to 3, 1 by 2, 1 minus 1 by 2 is 1 by 2. So, no change of sign. So, 2 into 1 plus 3, 4. So, it will be plus 8, this plus 8. Okay, so, you see if you add the two, 8 into 1 and minus 7 into 1. So, you get 1 and then minus 8 by 6 x plus 7 by 3 x. 8 by 6 is 4 and 3. So, minus 4 by 3 plus 7 by 3. So, basically plus 1 divided by this, which means you get back your 1 plus x divided by, all right. So, now you replace z by z inverse. So, your h z will be 8 minus 7 by 1 minus 1 by 6 z inverse, x you put back as z inverse, plus 8 by 1 minus 1 by 3 z inverse. Okay. This part has a pole at 1 by 3. If z is 1 by 3, it is 0. So, its ROC cannot contain 1 by 3. So, it will be either outside 1 by 3 or inside 1 by 3. That is, draw a circle of radius 1 by 3. It will be either inside the circle of radius 1 by 3 or outside, but it cannot be including the circle of radius 1 by 3, because on that circle z can be 1 by 3. If we have a circle of radius 1 by 3, z here is 1 by 3, this point. If you put that z, this is 0. So, this is a pole. Okay. So, this circle cannot be part of this ROC. Z mod z cannot be 1 by 3. This cannot be. So, either inside the circle or outside the circle, but we are giving this to with ROC. So, we have to conform to this. So, this is inside the circle. So, for this we will take the ROC to be this part, and this again has a pole at z equal to 1 by 6. So, ROC for this will be either outside a circle of radius 1 by 6 or inside a circle. We will take outside, because this is what is given to us. We have to. So, for this it will be mod z greater than 1 by 6. So, for the overall, it will be the intersection between the ROC of this and ROC of this, and then you get this mod z less than 1 by 3 from here, mod z greater than 1 by 6. That is the overlapping region, intersection of the two ROCs. Now, when you have this, you remember I consider this expression 1 minus a z inverse, but if mod z is outside a circle, okay, there is mod z is greater than 1 by 6, it is outside a circle, mod z is greater than, okay, it is of the form minus 7 by 1 minus a z inverse, a is 1 by 6 here, and ROC is mod z greater than mod a. Mod a is same as a, because there is a real positive number 1 by 6. So, it is conforming to this form, mod z greater than this a. Mod a, in this case a is 1 by 6. So, mod of that is 1 by 6 itself. So, and mod of z greater than 1 by 6 is the ROC. So, the ROC is outside the circle, it is of this form. So, this will give rise to minus 7 as it is, and then this a to the power n u n. So, a is 1 by 6, 1 by 6 to the power n u n. Okay, because 1 by 1 minus a z inverse, 1 by 1 minus a z inverse, mod z greater than mod a, mod z greater than mod a, 1 by 6 is mod 1 by 6 itself. So, for this will be, and in this case it is of the form 8 into 1 by 1 minus say a z inverse, a is 1 by 3, but ROC is mod z less than a, less than mod a. Okay, this one. Same expression 1 by 1 minus a z inverse, 1 by 1 minus a z inverse, but ROC is mod z less than mod A is 1 by 3. So, mod A is same as A, because 1 by 3 is positive real. Okay. So, this will have this kind of sequence as inverse Z transform. So, it will give rise to minus 8 comes as it is, A to the power n, A is 1 by 3. So, 1 by 3 to the power n u minus n minus 1, all right. Okay. In the early part of next class, I will consider one more example, and then this topic will be over. We will move to next topic, that is discrete Fourier transform. Thank you very much.